we have 1 minute, and let's open up. Basically, the webinar itself. I mean, at the EIP, we have been really working a lot on this sort of industrial energy efficiency for over 10 years. And quite early on, we came across the issues of manufacturing as a service. At the time, it was about 10 years ago, we have contacts with the DHL and some of the logistics companies that actually they were looking to move into manufacturing provisions for their clients. So it's very topical for us, this. And also kind of flexibility is one of the real kind of cornerstones of both competitiveness, but also sort of energy sustainable industry. You can put the slide, yeah. So basically, it's timely. It fits, very much, into the discussions, which are currently in Brussels. And I think our objective is to, first of all, to kind of position manufacturing as a service as one of the elements of the future industrial policy. And then also, secondly, to try to kind of raise, a little bit sort of discussion on this. And then, finally, to kind of really showcase the work has been done at the DMaaST project. So to create sort of like, overall impression of the event, we invited Natalie Samovich to give a keynote speech, and then basically sort of to open up, sort of opportunities for us. Natalie, I mean, we've been working for Natalie for quite a number of years, and she's been very instrumental in Brussels here in IoT, but like, on Internet of Things and on basically kind of future-looking manufacturing. So she's definitely kind of one of the best people in Europe, to speak on this. And if I can invite you, Natalie, to give us your keynote, please.
Well, thank you so much for the introduction and opportunity and the challenge that you posed in 10 minutes to reflect on a number of topics and condense it to the most important messages. So first of all, congratulations on linking the topics of the energy efficiency, sustainability, and manufacturing. This cross-domain sector coupling, call it as you want. I think it's critical. Manufacturing is energy efficiency is decarbonization, and decarbonization is sustainability coupled with hopefully lower electricity prices. So that's a little intro. But for today, actually, I'm not gonna say anything about our manufacturing projects on purpose. I sort of challenged myself to do 3 things. So to present some of the challenges that I see that hopefully will be helpful to the project, shed the light a little bit on some things that are actually I consider to be good trends in this darkness in the moment. And share some of the insights as to the sort of fresh from the press, some of the reports that have been recently presented. So if we can go to the next slide, please. Yes, so I consider the challenge is the challenge of orchestration within the context of manufacturing as a service. And what type of orchestration? Orchestration on the at least 3 levels within the technology and the context. So it's the intersection of AI or upcoming AI. Let's face it, it is not there. I wish I could say the numbers of the adoption of AI inference and AI models in manufacturing, but at the moment I can't. So that's one of the challenge probably. The edge computing, which facilitates manufacturing as a service, and the clean technologies. So Net Zero Industry Act. Sorry for the noise on the background. And so overall, Net Zero Industry Act challenges that also can be unlocked and facilitated with manufacturing as a service. Of course, on the background of all of this is is acceleration of competitiveness. Within the current geopolitical conditions, it's a tough cookie on many levels, and technology on its own, without the policy, without the markets, cannot solve it, but definitely contribute to it. And the graphic on the bottom, I will go into some of the details of. So the topic of resilience in the context of energy and manufacturing, that's where the coupling comes in. And the sustainability context, I think, is wonderfully presented within the context of your project, so I won't touch upon that. So what you see on the bottom is something that everyone talks about, at least 1, 2, and 5. So the throughput challenges, the manufacturing yield, the quality assurance, the compliance, these are the concepts that very often appear. But if we're talking about the new concepts, right, and the new business models that would facilitate the competitiveness and address resilience and sustainability, then the topic 3, decarbonization of product and production, is a challenge. It's not addressed as much as the other 3, right? If you talk about the manufacturing companies. And the upcoming one that is only surfacing up, I would say, it's Industry 5.0, the intelligent worker enablement within the context of knowledge retention, aging workforce, a lack of basically interest into the joining manufacturing, which is not high tech. So these 2 areas I consider as potential positive challenges. So that's where the good can come from, so to say. If we can go to the next slide. So these are some of the topics that I would like to discuss briefly. And Dušan, please tell me when they're going to be 3 minutes till the end for the timekeeping. On the bottom of the slide, I'm already leaving something with you that might be useful in the future. Is some of the references on the freshly published work from the AIOTI. We published the AI in Energy paper, which also has the topics on the interface with the manufacturing, because we work very closely with the manufacturing working group, and the paper from the manufacturing working group is the next one on the list. The topic that I singled out as the good and potential hope is the virtual worlds paper that also fresh from the press, the immersive technologies and virtual worlds, and I link it directly to the HR and the knowledge workforce challenges. So not only from the technology standpoint, but also from the facilitation of the point 5 or point 4 in the graphic that I showed before. And I also welcome you to have a look at the proceeds of the policy session at Sustainable Energy Week, which is called Electrifying Industry, Unlocking Flexibility and Innovation for Decarbonized Future. It is mouthful, and it also was content full and challenges full. I think these are sources that are going to be relevant for the project in many ways. So these are going to be with you. So the policy context, of course, I couldn't not mention some of the Draghi reports, but most importantly, where we are with the implementation of Draghi report. And DNV report, which just was released on the energy and energy intensity of manufacturing worldwide, since sustainability is one of the topics of the project. Then cannot stress the importance within the Net Zero Industry Act, the relevance of cloud edge computing continuum, and the importance of these sovereign data infrastructures, so the AI compute and as well as cloud infrastructures, because without adaptation of those, we're not going to get there. And the business models and the governance of the data spaces that facilitate one of the use cases, of course, is manufacturing as a service. So another very related work is taking place right now at ETIP SNET. So we have the task force on the flexibility, which is flexibility of buildings and industrial clusters, right? So the concept of the cluster and within the manufacturing as a service, that's something that I would like to leave with you as well. So sovereign infrastructures, as you might have heard in some of the keynote speeches of Janssen Huang, is that the manufacturing of the future, or manufacturing facilities of the futures, are going to be manufacturing facilities and AI infrastructures. So two in one, and so where they sit, how they're organized, and what use cases they facilitate, I think it's one of the challenges that you're going to deal with. Next slide, please. So, and now a little bit more of a challenges. One of the challenges, only 12% of the Draghi 383 recommendations are fully implemented. In relation to manufacturing, you see the progress is uneven across the sectors, and manufacturing is not in the lead there, and lesser so in digitalization and clean tech. Okay, so the message is not bright, and hence from the policy impact standpoint, there is still a lot to be done. The energy costs are important, and the dependencies are still major constraints. So within the format of sustainability, that's very important. And of course, for the implementation of the solutions or the platforms for value added and resource efficiency, there are still some uncertainties related to the AI Data Act, overall data, and on the operational side related to the permitting. But not all lost. So if you can go to the next slide, please.
Natalie, two minutes, please.
Okay, so as you can see, and you'll be able to inspect this a little bit closer. So this is the DNV Energy Transition Outlook for 2025, presented a couple days ago. You see the slide on the right-hand side that the CO2 emissions by the sector, while the power sector is decarbonizing quite drastically, manufacturing is sort of stuck there. Hence, contributions to the energy intensity in manufacturing would be more than welcome. Electrification is gaining momentum, and I think Dušan will recognize that. So it's hopefully going strong. But have a look how manufacturing fares against other industries, and for the comparison purposes also to see what others are doing to make it better. Next slide, please. So here I also did the summary of some of the paper main outcomes where the AI in manufacturing, as you understand, closely linked to the manufacturing as a service, but also let's not forget manufacturing as a service as a stepping stone. Now there are talks already about the combining additive, subtractive, and hybrid manufacturing, right? So the complexity increases. So don't stay within one context, explore other angles. So in point 6, the creation of new revenue opportunities is the one that definitely within the competitiveness drive will resonate the most. Next slide, please. Data spaces, that's where the it's a format where Europe hopes the data exchange would take place. Manufacturing fares quite well here, but this is not a done deal. There are various business models. I will leave this comparison with you that we did within the project in Système. The business model is usually anchored by the who leads the driving organizations and the formats. So the suggestion is to think of that from the get-go. Who's going to be supporting that going into the future? Next slide, please. And I would like to finish on the positive note. Yes, there are challenges related to the HR, related to the knowledge retention, related to the electricity costs, related to the also the compliance challenges, but there are also possibilities, and these possibilities are always on the crossroads with the societal challenges. So I welcome you to have a look at the industrial immersive and spatial computing applications and the potential of those within your project, manufacturing as a service or the hybrid manufacturing. More to come. Thanks, and looking forward to the to be informed as to the progress.
Thank you, Natalie. Thank you. I mean, this is excellent, you know, because it's really sort of like super informative, but it also sort of creates, you know, sort of not just a policy, you know, but kind of technology depth to our work. We already have a question about implementation, but, you know, I will kind of leave the questions, you know, if you can stay with us, you know, toward the end of the webinar. So I would like to invite Lucía Gálvez to tell us a little bit more about the actual project. Lucía, please.
Thank you very much for the introduction, Dušan. I will take control now.
Your microphone is a bit quiet again.
Yes. Check. Not really sure why it's not working. I will disconnect my.
I don't think it makes too much sense, you know, to kind of switch off, you know, like switch around the presentations. But Lucía, try now, please.
Hello, can you hear me now?
Yes, we can hear it. This is better. Thank you.
Okay. Then, yes, I'm able now to also control the slides. Well, thank you very much for the introduction, and good afternoon, everyone. I'm really happy to be here and share a bit about the DMaaST project. First of all, a slide again about the challenges of manufacturing sector. Well, manufacturing sector has faced a lot of challenges recently. An example of it is COVID-19 and also the Russia-Ukrainian war. These events showed how the manufacturing supply chains are really vulnerable, and we really need to work towards a solution. The European Commission is already working towards that, and some aspects such as the manufacturing as a service, which basically means having manufacturing services on demand with flexibility and with through platforms that are available in cloud computing and so on. These solutions kind of work towards being prepared for manufacturing challenges, right? But there is still a long way to go, because we need to develop the technologies to be able to use this and to implement those in the manufacturing sector. And this is where DMaaST project comes in. So DMaaST is an Horizon Europe project that was founded in 2024, and we are 12 partners spread around 10 different countries, and we have 2 demo sites. We will have at the end of the webinar a talk by one of the use cases. And let me share a bit more about the objectives. Our main goal is to reinforce manufacturing value networks resiliency. And this is a really great goal, let's say, but I like to divide it into several sub-objectives. So being the first one, the data interoperability and cross-organization data integration, which is really important. This sub-objective is attached with an innovation that we are going to develop and have within the project, which is the decentralized knowledge graphs. Ema, again, which follows my talk, will give more details about that. But basically, these are maps of information that enables us to have this data interoperability between companies and so on. Then another sub-objective is to improve manufacturing industry's anticipation to unforeseen events. And how are we going to do that? We are going to implement digital twins, but not any kind of digital twin, but cognitive digital twins, which means that these digital twins not only replicate the physical entity, but also take into consideration expert knowledge of people that works within the manufacturing sector. Then the next sub-objective is related to the ability to respond to threats while optimizing industrial production. And this is attached to the creation of a multi-objective decision support system for being able to understand which is the best strategy. And last and importantly, as Natalie has been explaining also, to improve the sustainability and circularity opportunities that we have within the manufacturing sectors. Then again, we have 2 use cases. One of them is related to the aeronautic sector, and the other one is related to the electronics. And one is settled in France, and the other one in Denmark. It is important to note that we are not only going to take into consideration the production that both use cases have, but instead we are going to take into account the whole value chains that they belong to, because in this way we will be able to understand the whole manufacturing as a service concept, and we will take that into consideration when developing our technologies. Our main output of the project is going to be the Smart Manufacturing Assessment Platform, or SMAP, that you will see in the next slides. This is a platform that will enable the manufacturing as a service, and it's built with layers that build one on top of the other. So I'm going to explain briefly which are the layers and what each layer does. And hopefully this will make sense, but if any question arises, please feel free to ask them. So the first layer, I have been mentioning already that the data is really important, because we need to be able to trace the products and to connect with companies for implementing manufacturing as a service. And we are going to do that by the decentralized knowledge graph that is based on ontologies and also is security compliant with the exchange of information and so on and so forth. This data and information will also have a data streaming service that are kind of transversal within the project, because we need to exchange information between all the technologies that we are going to develop. Then another transversal aspect that we are going to develop within the project is the circularity and sustainability assessment module that will give us a sense on which are the opportunities for circularity that we have within the productions already existing and where we can improve, which is also, as I said, a transversal aspect that we need to take into consideration. Then we have the layer that builds on top of the data and has the digital twins. The digital twins are going to be in 2 levels. So in the production levels, we are going to model the services, and in the value chain level, we are going to take into consideration all the aspects that also affect the production per se. Having all this information, the multi-objective distributed decision support system builds on top of this and takes the information coming from the scenarios of the digital twins, from the circularity, sustainability module, and so on and so forth. And this studies which are the alternatives and which are the maybe bottlenecks existing, and it balance the different strategies in order to select the most convenient one and the one that hopefully will serve to give solution to the problem facing in the moment. And last and importantly, we are going to build this map with interfaces that are user-friendly and that are able to be used by different kind of users, so that the platform is not something that is isolated, but instead can be used by different people and really makes the difference and help everybody. So that was basically it for the concept of the project, and here I will give more of a detail on the consortium that we are working in this project. As I said before, we are 10 countries. We are spread in 10 countries across Europe. 9 of the beneficiaries are from the European Commission, and we have 3 associated partners, which are from Switzerland. And yeah, our expertise is really balanced with information. I mean, we have knowledge in data management, artificial intelligence, of course, sustainability, manufacturing aspects, and then, of course, dissemination. This leads me also to this last slide, in which I have drafted the work packages that we have within the project. This is just for reference, but yeah, we have one work package for each module or layer that we are going to develop, being the first one related to the sustainability and human-centered aspects. The second one is related to the ontologies and the decentralized knowledge graph. Work package 3 is related to the cognitive digital twins. Work package 4 is related to the development of both the platform and then also the multi-objective decision support system, and everything will be demonstrated in work package 5. Then again, work package 6 is communication and dissemination, and work package 7 is the management of the project.
Thank you. Thank you, Lucía. Thank you, Lucía. This is excellent as an overview of the actual project, and thank you for doing it really kind of super fast. We will proceed with the presentation on the project, and I would like to invite Ema Lovšin to present, her work and to show and to continue, this sort of to enable, more discussion on the project. Ema, please.
Thank you for introduction. So hi everyone, thank you for joining us today. My name is Ema Lovšin, and I'm the head of growth at Trace Labs, and we are the core developers of OriginTrail. So I'm very excited that I can share with you how OriginTrail Decentralized Knowledge Graph, or DKG shortly, is powering the future of autonomous manufacturing. So over the next few minutes, I will walk you through the challenges manufacturers faces today, how OriginTrail addresses them, and some of the innovations that we are already bringing to life. So I will begin with a simple but a very critical question. Can autonomous manufacturing really thrive if data remains siloed? So the answer is unfortunately not really, because siloed data limits the collaboration, it reduces efficiency, and it makes it really impossible to build the kind of intelligent autonomous systems manufacturers are striving for. So when production, maintenance, supply chain, and quality data operate in isolation, manufacturers loses the ability to spot inefficiencies, or predict issues, respond quickly to market shifts, and so on. So breaking down these data silos is essential for creating the connected, data-driven environments that enable smarter automation, more resilient operations, and continuous improvements across the factories. So here are some some of the biggest challenges we've seen in today's manufacturing systems, but they apply also to other value chains, other industries beyond manufacturing. But focusing on manufacturing, what's standing in the way of autonomous systems? Well, first, most systems still don't talk to each other very well. The lack of interoperability makes it very hard to get a full picture of what's really happening. Then there is scalability. That is also still an issue. You might have a solution that works fine in one plant or one supply chain or one other department, but it just doesn't stretch across the entire network. And even when it does, many of these tools aren't built to line up with modern standards or connect easily when some new technologies are planned to be applied. Then there are the questions of trust in the data. If you can't be sure the information you're working with is accurate, you can't expect AI agents to act on it reliably. And without that, true autonomy is still out of the reach. And of course, security and privacy are always concerns, especially when sensitive data has to flow between different partners or organizations. So taken together, these challenges create big roadblocks. And unless we tackle them head-on, autonomous manufacturing won't get the chance to reach its full potential. So this is exactly where OriginTrail comes in. It gives us a solid foundation for building autonomous manufacturing systems. With the OriginTrail decentralized knowledge graph, organizations can link the data across the entire value chains without actually moving the data itself. So it can stay in the systems that they're already using, that the companies are already implementing them. That means that you get the security of keeping the data where it belongs, and while still enabling smooth sharing across different departments and even between different organizations. It also opens the door for AI-powered solutions that aren't just black boxes, because they're built on trusted data that can be verifiable. And because OriginTrail is based on global standards, it doesn't ask companies to rip out what they are already having, but instead it fits in, making existing systems interoperable. And all of this runs on a scalable blockchain-based infrastructure that brings the auditability, trust, and ongoing innovation manufacturers need to move confidently towards autonomy. So solutions built on the decentralized knowledge graph follow a three-layer architecture that combines trust, knowledge, and intelligence. At the foundation, there is a trust layer, which leverages multiple blockchains to ensure auditability, integrity, and transparency of the data on a global scale. Above it lies the knowledge base, or basically the decentralized knowledge graph itself, where data is structured, connected, and made verifiable, forming the backbone of a trustworthy internet or solutions. At the top, there are AI agents that not only provide intelligent insights, but they also remain accountable, predictable, as its outputs rely on verifiable data from the DKG. So this unique architecture makes OriginTrail decentralized knowledge graph a powerful framework for building an internet or solutions where trust, knowledge, and AI converge. So in the DMaaST project, we are using the OriginTrail decentralized knowledge graph to bring smarter collaboration to manufacturing. And the idea is basically very simple: to get the systems that don't normally speak to each other to finally share a common language using industry standards. That breaks down data silos and make information flow where it needs to. We are also putting end-to-end traceability in place, information about the products, for example, some certificates, data around the products, like second phases of the products and so on, through the entire supply chain or value chain is transformed into what we call knowledge assets, which are verifiable, self-describing data objects that live on the decentralized knowledge graph. So basically, you build decentralized knowledge graph out of these knowledge assets. So those knowledge assets are then tracked across the entire value chain, which strengthens the compliance and builds trust because everyone can see the same trusted version of the information. And to make this work across companies, we're using blockchain secure data pipelines that lets partners share data in real time while keeping privacy and control exactly where it should be within the data owners, within the organizations. So we're transforming data into the knowledge assets. We are turning raw data into the machine readable, verifiable assets so that the AI or other tools that are built then on top of that can make more predictable, autonomous decisions. So basically, step by step, we are showing through DMaaST project how OriginTrail decentralized knowledge graph can act as a backbone for future-ready, intelligent, and trustworthy manufacturing. And to wrap up, let me briefly summarize what OriginTrail is. It's more than just technology. It's an open, decentralized ecosystem that enables trusted knowledge exchange across many different industries. For example, it already secures around 40% of US imports, makes over 190 million train path kilometers saved. It connects more than 200,000 professional certificates and helps treat many patients securely. Because breaking down data silos, ensuring information is verifiable, and powering AI with transparency and accountability, OriginTrail decentralized knowledge graph is becoming the backbone of the next generation of autonomous systems and the agentic AI. So at Trace Labs, we are proud to be part of the at the core of the journey. Working alongside global leaders, for example, Microsoft, Walmart, British Energy Institution, GS1, and others. And we are always eager to collaborate with other partners, new partners who share our vision of building more trustworthy and intelligent digital future. So thank you very much.
This is super. I mean, basically, yeah, you know, you kind of continued on the upbeat note that Natalie also shared at the end, and it's so many opportunities and really lots. Before we get to the discussion, we have one more presentation from Charles Francout. And then, you know, if you have any questions at any point, you know, please raise your hands or put your question in the question in the chat here. Okay, thank you, Charles, please.
Okay, do you hear me well? Okay, thank you. Hello, everyone. So thank you for this introduction. So as mentioned, my name is Charles Francout, and I am the European Affairs Advisor for JPB Système. So JPB Système is a French SME located near to Paris, but we have an additional production plant in Rzeszów in Poland and a commercial office in the United States. So since the company creation, we have experiences a continuous growth, and now we employ around 200 people. So our core activity is providing self-locking technologies to engine manufacturers in the aerospace sector. For example, you have some names in this slide like Safran, Pratt & Whitney, and Rolls-Royce. But thanks to our expertise and our internationally innovative solution,
Charles, just 1 second. Do you want to change the slides yourself, or you need to take control?
Yes, it's okay.
Okay, for me. Sorry. We're not trying to rush you too much, but you know, please keep it in the wraps. 5 minutes. Thank you.
No, just as I said, so thanks to our technologies, we are diversifying our activity into defense, transportation, and energy sectors. So our technologies focus on the mechanical self-locking solutions that secure and ensure the reliability of equipment while reducing associated maintenance costs. So for several years now, we have been developing a new family which is an electronic solution. Among them, you can find, for example, the ball track, which is defined like a tension sensor, that monitor the tightening level of equipment in real time and helps reduce maintenance cost through predictive maintenance planning. So now regarding the DMaaST project, we choose to focus the project on one of our best-selling products that you can see on the left of the slide, the Lulilock. So the Lulilock is a fluid and gas coupling connector that ensures the safety and the security of pipelines. So here you can see you have the main characteristic of the product. And so we selected this product because it represents a significant portion of our turnover, because also we produce a larger number of units each year, and mostly because we have a fully automated production line dedicated to its manufacture. So here, yes, no, sorry. Little delay. You avoid one slide, but I wanted to mention this production line where you have a robot which allow us to collect the first layer of data, including traceability, productivity, and other key indicators useful for an initial flow analysis. So as I presented before, our role inside the project is to provide all available data for the Lulilock production across the entire value chain. That means from the delivery of raw materials to the manufacturing process until the final customer delivery, and covering economic, environmental, and social aspects. So to finish, I wanted to focus a little bit on the main challenges we face in carry out the project. First is to provide reliable data to feed the digital twin in order to obtain a scalable, and robust tool that fully meets our needs. And second, it's also to integrate technologies and mostly sensors to collect data that the project needs, especially in terms of environmental data. And also is to involve all the end users of the digital twins since the design stage, so which can be difficult in SME working under tight schedules, and with internal partners who may struggle to imagine or understand what the digital twin truly is, or what the benefit it provides. So finally, I could say that in terms of expected outcomes, our main objective within the project is to obtain a comprehensive view of production flows, enabling analysis of inefficiencies across the entire value chain, and supporting decision-making both at operator and management levels. For a main goal that is the global optimization, but also the local optimization through cognitive functions that learn and adapt over time. And also, it's the project will help us to accelerate our digitalization, our strategy of digitalization to maintain high standards that allow us to remain market leaders, and also to position ourselves as a European reference, of course, among innovative SME fully integrated into Industry 4.0 and moving towards Industry 5.0. So I try to make it short.
Thank you, Charles. I mean, this was sort of like, sorry for the slides, going kind of back and forth, but we're, we are trying to follow, the discussion. But just, we already have a question here in the chat, and I think, if the speakers and whoever wants to speak, they can switch on their cameras because it just looks kind of nicer. I think, one of the elements, that we could kind of really sort of connect, and it comes to me, as a sort of very broad range, from really kind of hardcore manufacturing, to something, which is sort of all encapsulating cloud computing. I think there is opportunity for us, to really kind of connect, more, these discussions also with the kind of softer policies, here in Brussels, like related to competitiveness, jobs, just transition, because I mean, we are largely here talking about SMEs, and we're talking about the jobs, which are created, which are very much on the local level and around the regions. So I think, Rod, if you want to ask your question or if you want me to read it, but basically Rod's question is about, it's about like, really kind of working out, kind of how do we bring it up, to the market. But before anybody answers, I just want to make sure that, that there are manufacturing partnership days coming up next week. I don't know, Natalie, will you be there? This is EFRA organizing. Unfortunately, I will not be attend, but, all us and few colleagues, from the project will be there. So this is one point, but like if anybody has any questions, now is the time to ask. Okay, I mean, I can go through. Basically, we have a question in a chat from Rod. I mean, he put it to Natalie during her presentation, but maybe Rod, if you want to kind of broaden up, your question, both kind of broaden it up, but make it a little bit more kind of tangible, so that some of the other colleagues also can understand. Not kind of how to bring everything to the factories, because
you're right. I mean,
we can talk about hours on that.
This is really quite exciting, what the project and also what Natalie was saying. What I worry about is that there's so much happening. It's so dynamic that I worry about the little factory in small town Europe, middle of France, middle of Hungary, middle of wherever, how they're getting to understand this. And I used the question, or other trusted voices. What I worry about is untrusted voices, that they may be getting misinformation and so I don't know how we tackle that. Well, just listening to the last speaker, it made me think that we should also be talking to the members of the European Parliament in the Industry Committee, that they need to know some more, and because they go back to their home country every weekend and things like that. But it's the whole question of communication at that high level discussion, and how do we massage the message so that the little person can feel part of the process, and it's not just a top-down thing, but that they can actually participate,
Who wants to try to crack this egg? Natalie, Charles.
I can share some thoughts on this. As you could see from the Draghi report, 1-year assessment, scaling up of technologies and manufacturing as a service as a platform with the stack of technologies below that, right? So that's the category I think it belongs to. So the one of the biggest challenges is the scaling up not only on that granular level that Rod described, right, within the member state, but also across the member states. Because if the technology is adapted in 2-3 facilities, is that good enough for the company that is providing this solution that Charles described, right? Is it good enough that it's just, picked up on such a small level? No, it is not. So that's harmonization basically on adaptation of these technologies is a big challenge. It's being discussed on all the levels right now, not only within the manufacturing, but within energy, within mobility and other topics. So to Dušan's question is, yes, this dialogue, and to the challenge that Rod mentions, there should be a harmonized approach to that. So that's one comment, and this second one is related to the first slide that I mentioned with the blocks. You know, if you talk to the smaller manufacturers and they're saying continuous manufacturing, right, or with the process manufacturing, they're saying, oh, you know, my yield is fine. You know, I have 3-4% rejects. You know, why do I need something extra to that? What is my value proposition to be part of these platforms? It is complex. I don't have additional people. It potentially could be disruptive, et cetera, et cetera. So it's not only the adaptation, but also a bit of a resistance, because everything is at the margin, right? So it's a little bit compared to the agriculture sector, because the margins are so small, and because there is such a small tolerance to error and experimentation. An example from energy sector is there was a setup of the testing and experimentation facilities, TEFs, where this experimentation, showcasing and potential adaptation can take place. So maybe it is one of the formats, along with the validation, that can be done safely. But I don't think there is a magic bullet how to scale up these technologies at the zero risk cost and zero failure opportunity.
Thank you, Natalie. Any of the other speakers have any thoughts on what we're discussing? Lucía.
Actually, I was thinking that besides what has been said, it is also a matter of to what extent the technologies can be able to tackle all the challenges that different companies may have. Because if we are talking of, I don't know, a small company, a small factory, maybe it's not easy for them to integrate big kind of technology, or maybe they don't see the use on doing that. So yeah, it's also a matter of trying to be able to develop technologies that are able to generalize, to be of use for big companies, but also for smaller ones that needs maybe less functionality, not functionalities, but you know, aspects to be reflected in the technologies. And yeah,
This is definitely the case, because also from my experience on manufacturing as a service, you hit on the sectors which are not kind of traditional manufacturing sectors. So you also have like people from logistics, and you have people, you know, because this sort of flexible and open-ended and open-entered manufacturing is sort of quite broad. I mean, we are already we're already 9 minutes over the time. I mean, we are definitely looking to continue this discussion with the future webinars that we are planning. I'm sorry that, I mean, we haven't really had hands raised here, but I think, you know, I feel, you know, we had a very kind of good, you know, sort of opening discussion, and it's not that, you know, we managed to crack the nut, you know, but I think the opportunities we have in manufacturing as a service, and also the work has been done in the project like DMaaST and elsewhere in the policy here in Brussels. I think it makes all of these things that we are doing, you know, very, very relevant and very, very topical. So I will have to continue this, and I'm sorry to say, but you know, we'll have to kind of close down because we're already losing people and we are 10 minutes over. But thank you all much for attending, and a special thanks for the speakers. And Natalie, thank you so much for your keynote. And we do hope, we'll have opportunity to kind of continue our engagement on these important topics. And thank you for mentioning electrification, as you know, it's my kind of favorite things. Okay, but thanks everybody. Thank you all.
Thank you.
Thank you.
Thank you.
Have a nice day.
Bye.
Bye.
Bye-bye.